Madam- Respected Madam, Sirs, this is Pavan Sai from CSE AIML from the Section C. Today, we will be exploring fundamental yet fantastic topics in electrical engineering. The topic is parallel connection for different types of load and how to calculate the current through each load. So, parallel circuits are essential in daily lives, powering everything for household appliances to the industrial machinery. In the talk, we will be discussing about how parallel circuits work, focus on three types of resistive, inductive, and capacitive, and we understand how to determine the current through each. By the end, you have a clear understanding of the concept and it's practically important in designing efficient electrical systems. What is parallel circuit? Basically, a parallel circuit is a type of circuit where all components or loads are connected across the same voltage sources. This also means the voltage across each load is identical to the source voltage. The, the current, however, is divided among the load depending on the individual characteristics. One key property of parallel circuit is that if one load fails, the rest continues to operate independently, a feature that makes them widely used in real-world systems. So here, voltage in a parallel circuit. So there is a constant voltage and an equivalent voltage. So in constant voltage, the voltage across each component is in a parallel circuit is the same recklessly or the resistance of each branch. This is because the voltage is distributed across all branches in equal voltages, as we can see in the analogy of a water system. Here, there's a diagram which represents some numericals which also refers to a resistor in them. So the voltage is like water pressure. Imagine a pipe split it into multiple small pipes. The pressure remains the same in each branch, just as the voltage remains constant in parallel circuits. There are types of loads in a parallel circuits. So let's now look at the three common types of loads: resistive load and inductive load and capacitive load. In resistive load, the resistive load, like heaters or light bulbs, converts electric current into heat or light. This relation is between voltage, resistance, and current is defined by Ohm's law. Ohm's law's formula is I equals to V by R, where I is equals to current and V is equals to voltage and R is resistance. In the inductive loads such as electric motor or transformers store energy in a magnetic field. This current is inductive, load lags the voltage due to the inductive reactant XL is also calculated by XL, which is equals to 2 pi F into L, where F is the frequency and L is the inductance. The total impedance Z is the inductor load, combining resistance R and reactance XL. Z equals to root of R square plus X square L. This current is then calculated as 1 equals to V by Z. So the third one is capacitive load. In capacitive load, like capacitors or certain electronic devices, stores electricity in a magnetic field. This current in capacitive load leading the voltage because of the capacitive resistance Xc, where Xc equals to 1 by 2 pi into F into C, where C is the capacitance, and similarly in the impedance Z equals to root of R square plus X square C. Here the current is 1, which is equals to V by Z. So current division in a parallel branches, it is divided into three currents: total current, branch current, and current division. In total current, the total current flowing into a parallel circuit is the sum of the current flowing through each branch. Branch currents, the current is in each branch is determined by the resistance of the branch of the voltage across it. The current division across the each bunch is total current remaining the same. Ohm's law and parallel circuits consist of resistance, voltage, current. Resistance. The total resistance of parallel circuit is less than the resistance of individual branch. The formula for calculating the resistance is 1 by R total, which is equals to 1 by R1 plus 1 by R2 plus so on. So the voltage is the same across of all branches in electric in a parallel circuit. Current, the total current in a parallel circuit is the sum of current in each branch. Advantages of parallel circuit: independent operations. We can perform some operations separately without doing, like, we can do multitasking. The components in a parallel circuit operate individually. If one component fails, the rest continues to function normally. Uh, this is essential for household wiring, allowing multiple appliances to work without affecting each other. So the constant voltage, all the components in a parallel circuit receiving the same voltage. This ensures consistent operations to all devices connected to the circuits, providing a reliable power supply. For example, all lights in a house typically have the same brightness because they are connected in a parallel circuit. So how current increases with more branches? So as the number of branches in a parallel circuit increases, the total current increase proportionally. This is because there are more paths for the current flow, reducing the overall resistance of the circuit. Reduces resistance, adding branches reduces to overall resistance, allowing more current to flow through the circuit. Think of it like adding lanes to the highway. More lanes allows more cars to pass through, as a branch allows more current to flow in a parallel circuit. Total current. The total current flowing in a parallel circuit is the sum of the current flowing in each circuit with more branches. The total current increases by making the circuit applicable and handling more current. Practical applications of parallel circuits. We use it in holiday lights whenever there's a Christmas or a Diwali. We usually decorate our houses with lights, which consists of bulbs. In these lights are connected in a parallel connection. This ensures one bulb to burn out and the remaining lit. The computer motherboards consist of very large amount of circuits and parallel components which receives power independently, ensuring optimal performance. Car electrical system. A car electrical system have a parallel circuit, like for example radio and other electrical appliances connected in a parallel function independently. So troubleshooting parallel circuits starts by identifying the faulty component. A component commonly symptom is a manufacturing device or a open circuit. These helps us to test individual branches, replaces faculty components, and test the circuit. Importance of understanding parallel circuits. Electronics, basically parallel circuits are the fundamentals to electronics, using in various applications for household wiring to complex electronic devices. Power distribution, understanding parallel circuits in crucial for power distribution system, ensuring reliable electric supplies to homes, business or industries. Problem solving. Knowledge of parallel circuits is essential. Troubleshooting, electrical problem solving, and effective operation of electrical systems. Parallel circuits, understanding the relationship between current and resistance. So this presentation explores the relation between current and resistance in a parallel circuit. In this we discuss about unique characteristics of parallel circuits and how they function differently from series circuits. So introduction to parallel circuits. Parallel circuits are the circuits which are connected in the parallel sites, which can also operate independently. Key features: the components are connected across each others, allowing for different paths for the power supply and each component. So Definition for total current and individual branches current and resistance. Total current IT, individual branches I1, I2, etc. And the resistance R. So relation between resistance and individual branches current. Voltage is constant, current is the resistance, and Ohm's law. Uh, okay. So how adding more branches affects the overall resistance? Decrease resistance, increase current. How adding more branches affects the total current? Increase total current. Adding more branches reduces overall resistance, leading to a increase of flow of current. As we can see, is a diagram of bulbs and a switch which is connected to a battery. So advantages of parallel circuits: independent operation, constant voltages, and the flexibility. Independent operations, basically when one branch fails, the other remains to work. The constant voltage, each branch receives full source of voltage, ensuring consistent performance with the equal voltage distributed across the circuit. Every component receives the same voltage. Flexibility, easy to add or remove component without affecting the rest of the circuits. This process, uh, these is the advantages of parallel circuits. So whenever we want to change or switch the components, it doesn't affect the remaining components. They still continues to work. The practical applications of parallel circuits, we use them in our studying table lights and our festival lights when the festivals of Christmas and Diwali in India. The conclusion and the key takeaway: parallel circuits offers distinct advantages for power multiplying devices with constant voltage, making them valuable components. In various applications, understanding relation between currents and troubleshooting of the parallel circuits. So, we use these applications from this whole concept in our real world. Parallel circuits in everywhere. In our homes, we use in lights, fans, appliances are connected in parallel for independent operations. In industries, they use motors, transformers, and other equipment are managed by using parallel circuits for reliability and efficiency. In electronics, devices with mixed reactive, inductive, and capacitive components rely on parallel configuration. Understanding how to calculate the current through each load, ensuring the circuit operations effectively, safely, and without overdoing any component. So I want to conclude with the parallel circuits. They are vital in electrical systems due to their availability and maintenance and constant voltage, and allows independent operations of loading by applying Ohm's law and impedance formula. We can calculate the current through resistance, inductivity, and capacitivity loading in such circuits. Mastering these calculations is not only important for theory knowledge but also solving real world engineering problems such as designing reliable power systems or troubleshooting electrical equipment. Thank you for listening, and I'm happy to take my questions you may have. Thank you.